Okay, so what are boundary works for various processes? Okay, how many processes did we talk about last time? Well, we know, I did ISO something. Okay, ISO, choric, isothermic, and I think adiabatic, right?
Yeah.
But I'm going to do when pressure is not constant. Constant. 1, 2, 3, 4. Okay. What does isobaric mean? Okay, that means isobaric means delta P is
0.
What does isochoric mean? What does isothermal mean? And I can't quite explain that. Okay, so let's discuss. What do I know about delta P equals 0? Okay, if I write my first law, what will it look like? Okay. So when I have isobaric processes, how do I write the first law? I write it as delta U equals Q plus W. And how do I write useful work? P is constant, correct? Useful work was defined as negative P dV. May I rewrite this as negative P delta V? Because pressure is constant, it can be taken out of the integration. And how do I graph this? PV. Are we ready to do the next one? Isochoric. What happens when delta V goes to 0? When delta V is 0, that means dV is 0. That means work must be, which means I can write the first law as? Very good. There's no work done. Okay, next step, isothermal. Delta T equals 0 means what? What equals 0? No, not quite. Where does T show up in the first law? Heat, Q is heat. W is work. Where's the only place where T shows up? So there's 3 symbols in the first law. Q, W, and U. Where's the only thing that changes when temperature changes? U, right? So if delta T is 0, what is 0? Delta U is 0. Which means I can rewrite this law as Q equals negative W. So when pressure is not constant, what does that mean? P changes, which means W will now be written as P dV.